Tudo certo?
Certinho.
All right, so good morning, everyone. Thanks for coming. We have today Caio Villela, who will present us some of the work he has been doing at Refik Anadol Studios in Los Angeles. And the talk is from Signal to Sense, Designing Interfaces with Gen AI. Caio is an AI researcher and engineer there at Refik Anadol Studio. And he's going to talk to us about building creative systems at the intersection of machine intelligence, sensory, design, and human perception. Caio is a former student of ours, and everything started a few years back when I invited Refik Anadol to give a talk to us, and then he joined it. At the end of the talk, Refik said that he was looking for bright students to join the studio to continue research, but he was graduating, so he joined as a researcher. So today he's going to talk about the journey. So thanks a lot for being here. Do you think you can do it in about 45 minutes so we can have some questions?
Of course.
Perfect.
Of course.
Thanks a lot.
Awesome.
The stage is yours. Thank you.
Thank you. Hi, guys. Such an honor to be here, to be back here, especially after I got this job because of Anderson and because of a talk much like this one. So yeah, it's great to be back and great to share some of it with you guys. So I'm going to talk about the work that we conduct at the studio, some of the research that we have ongoing right now. I'm going to be sharing some of the techniques that we employ, but mostly an artistic overview of the ethos of the studio and the work that we develop. So I would like to start this talk by giving a bit of context on what I think about when I think of AI as a tool for an interface. To me, AI behaves as the most powerful transducer that we have. It is a translator that can abstract meaning. It can create relationships between entities of completely different universes and magnitudes. And within this internal reasoning or semantics or knowledge that it develops when you train it, numerous possibilities appear. We can think of seeing emotions or hearing images or smelling sounds. All of these possibilities appear before our eyes using this technology. I would also like to point out that as with any other translation, AI is not at all unbiased. There is a very conscious decision-making in this process of training AI for the arts and for generating any sort of interface. And I think that's where humanity lies in all of this. So the actual conscious action of deciding what to show and what to keep invisible is where humanity lies. And by no means using AI means delegating the creative process. I think that when you think through the development of these systems, as we do in the studio, some of the projects take, I don't know, from 6 to 8 months to develop. There is a lot of humanity that shines through. So, as Anderson mentioned, I used to be a student here at Unicamp. I joined in 2016 as a control and automation engineer graduate. And my time here at the University of Campinas was crucial for my development as an engineer and as a creative person. I did not have any technical background before joining. I did not know programming. So I would just like to very quickly present some of the things that I developed here and just a 5-minute introduction on AI and in my journey. When I first joined in 2016, I joined a research project with Professor Eric Fujiwara at the University of Mechanical Engineering, where I trained an AI model to decode force myography signals, so signals coming from the forearm of using optic fiber sensors, into hand postures. And I think that this really represents this transducer or translator kind of magic that I think AI has. How can you measure muscle activation from someone's arm and deduce what they were trying to do with their hands? So this really rang a bell with me. In 2018, I joined Unicamp Racing, which most of you guys might know. It's a drive student competition Formula SAE team that develops electrical racing cars. And I joined the team to compose the first autonomous car that was going to be set out for racing in the Americas. So I worked in computer vision, I worked in path planning for this car. Unfortunately, we weren't able to go to the competition in the US because of COVID, but it was a really great learning process and something that Unicamp gave me. I later joined the Griauli as a data scientist, where I worked with fingerprint recognition. It was also during the pandemic, so people weren't able to go to places and actually acknowledge that they were themselves. So some big institutions like Serasa and the Brazilian government, they started to hire Griauli to employ this app for recognizing the biometrics and making sure that people were themselves. And in 2021, I got my first interaction with NLP. I took a course that was a master's course here at the Institute of Computing with professors Rodrigo Nogueira and Roberto Lotufo. This is my final assignment for this course, and I was basically doing summarization in Portuguese texts. And this was in 2021, so not long ago at all. And it was indeed a challenging task at that time to create abstractive summarization in Portuguese, which is crazy when you think about where we are right now. Just 4 years later, summarizing any text is the easiest thing in the world with LLMs and everything. And this below is my my graduation project. I worked in signal processing for guitar. I was also translating signals incoming from the piezoelectric pickup in the guitar and translating that into microphones sounds. So sounds as if they were recorded in the studio. I was using WaveNet. It was my first interaction with generative AI for audio. The sound did not come up as expected, but it was close enough. Later on, I joined the industry. I worked at a startup called Motu in São Paulo. I worked in the maintenance team and in the operations team. I was basically mostly working as a data scientist, but I presented this crazy idea to the stakeholders and the CEO about using sound as a means for maintenance. We had a big problem with defining what types of problems a motorcycle had in its motors. And these were the most costly maintenances that we had in this company. We had around, when I first joined, there were around 3,000 motorcycles that were rented. It's a motorcycle rental company, basically. By the time I left, there were more than 50,000 rented, so this became a really big problem. And I presented this crazy idea, people bought it. I was using AI. I was using AI to predict what problems the motor had with sound. I noticed that the best mechanics that we had, this is a very POC, so later on it was looking better. But I realized that the best mechanics that we had, they were able to correctly deduce what problems a motorcycle motor had by putting a screwdriver in the motor and listening to it. So I was like, okay, if this works, why wouldn't I be able to do it with AI and some basic audio spectrogram transformer logic? And it works very well. It was implemented in many of the Motu's franchises. And yeah. But by the time I finished this, I was really hoping to join AI research. I didn't know if I was going to take a master's program, if I was going to go with the academic path, but I knew that I wanted to work with research and cutting edge, and Motu unfortunately wasn't the place that I could do that. So I quit by the end of 2022, and I was taking some courses into cloud programming and cloud logic, so Google Cloud, Vertex AI, all that stuff, AWS, trying to get myself more prepared for the, for working as a machine learning engineer in a business environment, maybe apply to some other country. And then I got an email from the Institute of Computing here at Unicamp. I had already graduated, I was graduated for a couple of years, but I thought it was very interesting using AI and art and technology and immersive experiences. I was fortunate to go to Japan in 2019, where I went to this very large studio exhibit as well from a studio called Team Labs, which is very famous for their works as well, and it really captured my imagination. And so I joined this talk. Refik gave this talk online, and it was very, very transformative. I was in love with all the projects. I was in love with the ethos of the studio. I really liked Refik himself. I asked some questions at the end of the talk, and then, as Anderson mentioned, he was offering research grants for Brazilians specifically. He wanted a single Brazilian in the team because he was working in with some projects in the Brazilian Amazon, mostly for language research. So he wanted someone that was versed in AI and at the same time spoke Portuguese. He also wanted someone to work exclusively in audio. So many things came together and it worked out. So I have been working there for the past couple of years. I joined in 2023, in June 2023, so it's going to be literally 2 years very soon. So the studio is comprised of around 30 members right now. Most of them are in LA. I would say that 20 out of those 30 reside in LA. Even though we all come from very different backgrounds, there are people from all over the world, speak all sorts of languages, come from all sorts of backgrounds. We have architects, engineers, neuroscientists, designers, XR, people who used to work in Hollywood and film industry, working with VR. Anyways, it's a very diverse team, and it makes a lot of sense to have such a diverse team in regards to the projects that we take. So these are some of the projects that the studio has built over the years. This is in a chronological order. The studio is always trying to find ways to communicate through data, how to use data as a pigment and how to actually employ this knowledge or this, collective consciousness of humanity to show how buildings think, or to imagine how we can perceive knowledge through image and sound in the most diverse ways. All of these projects are mostly rendered in real time. They are all connected to the means that they're inserted into. So this airport, all of this are real-time flight data. This is a project called Bosphorus. It measures real-time inputs of wind and LiDAR scans of the Bosphorus Sea. So it's very, the ethos of the studio, or the main, I would say the protagonist of the work that we do, is the data itself. This is one of the first studio works I hadn't joined still. It's for a public library in Istanbul called SALT. It was one of the first major works to be done in real time for interacting with big archives. I think this was in 2014, and using VR sets, people were able to interact with millions and millions of recordings in real time, and it was at the time very, very innovative, especially considering the use of VR, which hadn't been employed that much. It was in 2016, I'm sorry. But I think that this will to actually use and interact with big knowledge databases, or to interact with knowledge itself in a very raw form, is what moves the studio. This is something that appears across various works. We are employing UMAP for this. UMAP is a dimensionality reduction technique. These are millions of recordings from Rumi. Rumi is a Persian poet from the 13th century. We were contacted by a foundation in Persia to employ this work. And here we can see each point is one of his poems. And we trained this AI to basically create the relationships between each of his poems and provide ways for us to kind of try to grasp the magnitude of someone's work or someone's life work. This is another project we did for Mozart. This time we are using audio embeddings conditioned on music knowledge to actually try to get a better understanding of Mozart's work. It's a visual representation. Here we are reducing the dimensionality for 6 dimensions. 3 are used as colors, 3 are used as positions. And yeah, I think that this way of using AI in order to not summarize, but in order to actually visualize what would otherwise be unseen is what really moves us. Another big step in the studio technical projects is the use of GANs. When GANs were first released at Google, Refik was working there. He had a grant there to work as a researcher. So we were one of the first institutions to actually use GANs and use AI for visual thinking and exploration. And the concept of using latent space as a means to navigate all of this knowledge has always been central. So working as an AI engineer or as a data scientist at the studio really means creating the tools that make creating art possible with technology. So most of the time we are always thinking of interaction, we are always thinking of real time, and we are always thinking of empowering other people to also create. So this is a tool that we developed. It's called the GAN browser. Alex is a studio member who actually developed this. It basically, you can load various different data sets. By the way, we have processed over 4 billion images since we joined the studio. This is a latent space representation of a very large data set of California natural landscapes. And using a PS5 controller, as you guys saw, you can navigate this space. And in real time, using a combination of these latents that you are seeing right here, we can generate a final output that changes as you navigate. This requires monster computing possibilities, which are only possible because the studio has so much support from big tech or NVIDIA, Google, in order to create this cutting-edge research. As you see, it's really using AI for creating this type of work. To me, it seems very magical because using the empty space between all these pictures, we can create something that could have been, or something that we can imagine existing in the middle of all this existing knowledge. This is another layer of abstraction that we employ at the studio. So basically, coming from this GAN browser or GAN interpolation technique, we also create this fluid dynamics simulations. This is it has a lot of layers into it, and people usually look at our work and think, oh, okay, everything is very similar. But each project is very, very different from each other. We use very different techniques in order to try to capture the movement or capture the intention behind the data using these fluid simulations. And yeah, a lot of optical flow, a lot of image processing goes into it. I think that's one of the main projects in the studio, and something that really took the studio to new heights was the MoMA collaboration. MoMA actually reached out to us to create an exhibition. Basically, the idea here was to imagine what could have been in modern arts or in contemporary arts using machine learning, we analyzed an open sourced database of MoMA. It's all on GitHub, by the way. I think it's maybe 300,000 paintings. And employing these techniques, we were able to imagine modern art, or imagine concepts that could have been but haven't, and explore this whole universe of knowledge that's a part of modern art's history. So the idea is never to generate something in the style of Van Gogh or in the style of any artist. The idea is actually to try to employ AI to do things we couldn't create otherwise. So to actually try to employ it as a means to create something new. These are some of the examples running at MoMA. So as you guys can see, this is similar to what I showed before in the GAM browser space. We are navigating between a latent space of all modern arts, employing very various techniques. This is a giant LED screen, as you guys can see. So all of our models, we have to necessarily change them to export, very high quality in order to use in big projectors or in order to use big LED screens. So it was was almost a year's work to do this. Every artwork that you see is generated in real time. So nothing here is pre-rendered, and nothing is ever the same. It's creating paths between this latent space and crafting all these artworks as you see it. And one thing that's very cool is that this is the lobby where the work is. Here we have a microphone and a camera, and this also impacts how the artwork is generated in real time. Depending on how many people are there, or the movements of the people in the lobby, or the sounds that they are making, the artwork actually will change and respond to this. This is just another example of the fluid simulation that I was mentioning. As you can see, minimal changes in color really influence how this is built. The movements of the particles are also influenced by external inputs, as I mentioned. And it's very mesmerizing. It was very interesting to see how the artwork community in general really took a liking to this project. It was very innovative. It was the first time that any museum actually any major museum exhibited AI. Later on, the exhibition was had its time extended twice. There are so many attendees. It made so much success. And later on, it became the first actual AI artwork to be bought by a museum. And I think it really opens a lot of possibilities for digital artists everywhere. Honestly, it was a very big occurrence. This is a data display that goes by the piece. It's literally right next to it. It shows the process that's been employed in real time as well. So I think that's always something that we aim to do. It's not magic. It's not like we are prompting something and let the AI offload all of the process to the AI. There's a lot of thought put into it, and how we actually correlate these signals or these latents is a very conscious process, as I mentioned. So this goes right by the piece. People can see it in real time. It shows how the piece is being produced, shows all the inputs, wind data. And this is the behind the scenes. So as you guys can see, I don't know if you are familiar, this is the
front end and back end.
Yeah. Exactly. This is the back end. This is a DGX station. I don't know if you guys are familiar with this. It's a NVIDIA supercomputer. It has 4 A100 GPUs. Each has 80 gigabytes of memory, and it's full. I mean, the thing is like smoking, like in order to run this in real time in this quality. So it's a lot of work. We are so glad to have many friends at NVIDIA. That the studio actually has 5 DGX stations. I would say that sometimes they break from usage, but they are happy to replace it. So I'm happy as well. And yeah, this is just to show the backend, as Anderson put it. This is another GAN study called Flora. Here we analyzed hundreds of thousands of flower images from, I think, 20,000 different species. This is also being generated in real time, exploring the possibilities of what could have existed in the flower spectrum. And one thing that's very interesting is that for this specific project, we also collaborated with some master perfumists. I'm not sure how to pronounce this in English. Some master perfume creators. And we had actually, I want to say 500,000 different smell molecules or aromatic molecules. So as the flowers were being generated, we also were embedding the smell in the same latent space.
That's amazing.
And it was creating the smell in the room that people were witnessing the artwork. Imagining what could have been the smell of these flowers that we were interpolating or creating in real time. So this was a very cool project. I would say that the means through which we expose our work or the actual physical spaces is a big part of how the work is employed. It's all, of course, it's an aesthetic decision, but by the end of the day, having a means to actually express what we want to people and having a physical space really makes a difference in the impact that we want to show and we want to produce. I would say that you probably are familiar with this, the valence arousal charts. It's just a way to translate or try to very briefly summarize. Of course, this is not the whole spectrum of human emotion, but it's a way to try to summarize or discretize human emotion. And I think it's interesting to think of these spaces that we imagine that can join different fields of knowledge or feelings together. This is just an exemplification, but I wanted to show this piece where we are actually using music to generate the outputs in real time. By using music-specific knowledge to produce our latents. So if you use, I would say, let's say you have a generative audio model and you can get the last layers or the middle layers of an encoder, you can actually have very meaningful representations of music, and you can fine-tune that later into I don't know, an emotion recognition task, and use that as an input for creating those pigments. So this process of kind of chain thought and trying to abstract human emotion or human feeling is something that's very magical, and it's only possible with the technology that we employ. These are other GAN studies on nature. So this is a very recurring technique that we employ. This was commissioned by Yosemite. We were exploring over 1 million images of California natural landscapes in order to create this. This is just a small example of some of the actual work that we do there as a data scientist. It's very similar to anywhere else. You ingest the data, you spend a lot of time cleaning it, and spend a lot of time trying to train models, and later on employ it. This is a project that I did for the Cornell Lab of Ornithology. It's the biggest bird sounds repository in the world. Basically, this is just a classical audio pipeline.
Analog number 64145.
You first remove the speech. This is the no speech. Then you reduce the noise. And you finally remove the silence. So this was all also embedded into a latent space. It was we are employing various real-time applications with this, and it's very interesting to actually use it as a research tool as well. the latent space itself is very interesting, a very interesting tool, even for cleaning data sets as well. So you can embed new audio there and try to find similar, similar searches from what you have, and use that itself to manually create clean audio, which is many times more efficient than training a classifying head for any other tests. The same way that we have the GAN box for images, we have the same for audio as well. This is a pipeline that's being shown there for a project that I'm working on. Basically, we extract the features, and by sensorial input, so this can be biosensing data such as skin conductivity or heartbeats, or let's say wind data or weather data in different weather stations in the world, or camera movements or sounds. You can kind of compel the model to walk in the direction that you want it to, so it generates more sounds that actually talk and discuss with how people are feeling at that time. This is just a simple example. I just wanted to show you guys. This is all diffusion audio that was generated, and it's very high quality. Unfortunately, I don't think that you can listen to it very well, but it's very interesting. One other great, I think what's really one of the first things that the studio went after was architectural studies. So how do buildings actually interact with the spaces surrounding them? Buildings carry with them the stories of the places they are embedded into, or where they're constructed, the cultural differences, the weather, how the building itself is being used. So actually trying to use AI to translate that into the building facades or the interior is one of the big inspirations for Refik. This is a project that we did for Casa Batlló in Barcelona. It was a real-time exploration and AV performance of presented in the facade of the building. We are using many different sensors here. Because this is a UNESCO heritage site, there are so many LiDAR scans and datasets available. So we already have all the mapping of the building. We installed weather stations throughout the building to actually capture the data and see and try to understand how the building itself feels the city that it's inserted into. So another showing the weather data that we have. And these are simulations using this weather data on the facade. This within itself is very interesting to me. But I think that actually transposing it into the physical world is where the magic actually happens. So this is an AV performance that we held in Barcelona. It's a problem that I was having in my PowerPoint as well. So. Okay. This is a projection of all this that I was discussing beforehand, using the actual inputs that we collect from around the building to project and imagine how this building is through another lens, so making this invisible data visible. This performance had around 70,000 attendees in Barcelona. It was recommissioned again, and later on this became a permanent installation inside the building. We were using dozens of projectors to actually map out the building. This is reacting to the weather data in real time, to the wind. And yes, it was a huge success. Overall, it was just beautiful. This is a picture of the people attending. People later on went to hug the building, and they were very emotional, so it's very cool. So this is large. I want to talk about large nature model. This is the studio's latest big AI endeavor. It's a multimodal model that we are training exclusively on nature data. We want to make sure that natural data is actually well represented in AI. The idea of course, is to make a model that is as accurate as possible in different modalities. So for now, we have audio, text, and images. We are, but not limited to that. We are thinking of video. We are thinking of smells as well. Here are some of the partners that are helping us in this endeavor: NVIDIA, Google Cloud, Black Forest Labs. I know you guys probably know all of these. So it's really a joint forces collaboration. Here's some of the engineering that goes into it. We do have, so when we think about deploying such a big model, there's also the big engineering part behind it, right? So we have to run, hundreds of terabytes of data through pipelines. It has to be responsive. We have to make sure that we have, good stability for the users. So it's really been a big engineering challenge. The idea is to release this model publicly later, and for now it's being used a lot in our own internal projects. These are our data partners. So one thing that really I think sets us apart as a studio is that we always do have ethical data collection. So for all of these projects that I showed, it's the only institutions that provide us with the data. So MoMA provided us with their own data. It's a big concern to us. So Casa Batlló provided us with their own data. And here for the large Asian model, we have so many partners that are great in the scope. So Cornell Lab, as I was mentioning, the biggest natural repository in the world for birds, Smithsonian, the Natural History Museum, or Getty Images. And besides that, we also organized data collection trips all around the world for this first iteration of the model. The first iteration of the model is really focused on rainforests, so not everything as of now. So we went to 12 different locations. Here's a short film kind of showing the data collection process. We collected audio, video, LiDAR scans, sap flow measurements in trees, humidity, temperature to actually try to have a very well-represented view of what the rainforest looks like and what it feels like. We employed different professionals from all these various fields to conduct this data collection process. I'm gonna go a bit fast because I don't think we have much time, unfortunately. This is one of the first iterations of the model. We trained it with NVIDIA on the Picasso model. It's a foundational image model from NVIDIA, trained on Getty Image. We presented this at GTC last year, actually. So many of these slides are from GTC as well, actually. So here are some of the examples. It was very interesting to train this model. If you try to prompt for specific species in existing image models, they most of the times fail to generate something that's actually just closely resembles anything. And the model was actually pretty accurate. Of course, there are hallucinations, and that's inherent. We try to make that as low as possible using techniques like RAG, but the actual feel of the species prompting by scientific name or common name is very similar to the species themselves. I wanted to talk a little bit about audio, which is what I work on, of course. So this is a diffusion model that we trained last year. On top, we have the current state of the art on audio. It was released just this month by Declare Labs, which is from Singapore, and this is our own training of our own model in audio diffusion. So first, geese calling on a frozen lake. This is the current state of the art. The model that we trained last year goes like this. Because we actually collected data from these places and we were using a lot of binaural recordings and many channels, the model actually really learns about reverberation and about immersion in the space, in the sound space, which is very interesting. Here's another one. rainforest, Amazon rainforest. This is the current state of the art, so the best model that we have out there. This is ours.
It's much more immersive.
So much more immersive. It's crazy. The details.
And you are better than the state of the art 6 months before.
Yes. So, which means, like, of course, this is not a very, to make a fair comparison, of course, my model is not generalist. It's very good at generating rainforest soundscapes and nature soundscapes. The current state of the art generates music, speech sometimes. But yeah, to me, I think that it really exemplifies how data really matters a lot in the training. And of course, I did change the model a bit, and so I messed with some of the architecture and the inputs. And this, I created this, in a very fair manner. I was this week, the model released last month, so I did this benchmark for our own purposes. I tried many different prompts. I tried many different settings to have a, actual fair comparison. And so you guys are gonna have to believe me, but this is the best thing I could get for frogs in this state of the art model. And this is our own model. So yeah, it's very impressive. For this model that we were training, we're using employing diffusion actually, and not GANs anymore. The GAN aesthetic is very special to us, even more so because the studio is not always, it's never actually trying to get very, very, objective and real outputs. Most of the time we are very interested in the aesthetics of, this unknown or this kind of mixture of reality and dreams. But this is an output from diffusion, recently done by Heymin, which is a studio member. I don't know if she's here watching, but it's just beautiful. Seeing this in a big screen or big projection is amazing. And again, all of these outputs are really thought with interaction in mind. So having this interact with you as you see it is just amazing. And as you can see, this is also generated one big constraint in the studio in the technical space. I think it's interesting to mention is the aspect ratio that we output. Besides the quality of the image itself, having this projected in this aspect ratio is a lot of work because most conventional models are just designed for creating regular screen sizes, but this we dictated by the building facade or by the actual different types of screen that we employ. So it's a big challenge. This is the opening of GTC. This is rendering I don't know how many million particles, so many, in real time, and Refik is controlling them actually with the iPad. You can control the color, you can control the speed, you can control the movements, and of course later on we can just we can try to port these inputs to all types of sensors that we can think of. So, as I mentioned, Refik has a special relationship with the Amazon. He has many friends in the Yawanawa ethnicity in Acre, and he goes there basically once a year. He has lived there for many months, and here is him with the people there. And there are so many young artists there. So this is something that when he gave the talk here at Unicamp, he really caught me because, as a Brazilian. I thought it was very nice, and I saw the work that he was doing there, and I really believed in it. So that's one of the main reasons I wanted to join. He took the work from these aspiring artists from the Yawanawa and created this digital collection using also weather sensors that are there running right now to create these different artworks. This was all sold as NFT, which is a whole other universe. But every money that we got from this project was directly redirected to them. So this year they opened a very big convention center. They are building a school. So yeah, it's very great to see. The studio got zero profit from this. So yeah, it's just good people trying to make beautiful things. So it's awesome. So last topic here, I just want to talk about Dataland. Dataland is a museum that we are opening in LA end of this year. It's going to be the first AI digital exclusive museum in the world. What I think is very interesting about this is that we are going to have a space with all of the projectors, that are state of the art, and all of the sound systems, super immersive as smell sensors, to create this actual, very, very immersive, reactive space in downtown LA. And the idea is we are going to present the first iterations of the exhibitions, but this should be a space for any artist to go and present in the future. You can also visit the website. And yeah, thank you so much. That's it.
Caio, thanks a lot. It was very inspiring, and as you said, the word for this is mesmerizing.
Yeah.
It's very nice to see how AI can be used to inspire us to do different things, to show what we are feeling, and how we interact with the world. So that's why I'm a fan of Refik's work. I have the chance to meet him a few years back in an MIT conference, and then, of course, when I did it, I directly invited him to give a talk. And it's very nice to have you here today to show the recent works that you have been doing.
Awesome.
And of course, I'm looking forward to visit Dataland because it's going to be a very nice museum, right?
Awesome.
So we have some time for questions. So please, who would like to start? I'm going to start with another Kyle. So you come with a question. I'm sure that you have some.
Yeah, I mean, I was. We're friends from way back, so we talk a lot. But I have questions that rose during your talk. For example, I was thinking, how does the relationship with all of these industry partners come up? Because I think we're used to thinking that it's in the industry that the limits of hardware are tested, but here we see an example where not only an art and design studio, but also in research, you're testing the limits of hardware. You're breaking NVIDIA workstations, and they're replacing them because they want you to test them to their limits. How is this relationship with the industry, and how does this work?
That's a great question. So I think that Refik, during his career, was very fortunate to make a lot of partnerships with big companies. As I said, he was an artist resident in Google. He was the first artist resident at Google. But these companies, they come up to us in order to test out because honestly, I think one of the main reasons is these are giants, right? So Google, Meta, NVIDIA, I had a chance to work with all of them. And one thing that they all have in common is that they're very slow. So we have a lot of creativity, a lot of liberty to actually employ things in any way we imagine without having to go through so many different steps and bureaucracy. Also because with the visibility that we have, we actually employ them in various, very big projects that have a lot of attention. So of course, it's a way for them to market themselves as well. And because we are one of the good guys in AI, right? As I said, we are always using ethical collected data and trying to create projects not for profits necessarily. I think it makes us a very valuable partner as well in that sense.
Cool.
Very nice.
I have some.
Please go ahead.
Well, Caio, thank you so much for your presentation, and I've always enjoyed Refik's art, and I saw TED Talks, his TED Talk, and
That's
it was
awesome.
amazing. So we are, I work a lot in the philosophy of AI and AI for education and things like that. And we are surrounded by these discussions. I took some notes here, I'm sorry. on how AI can or cannot be creative itself. So, and eventually, of course, replace humans, which is every time we get questions related to that. So, regarding the ethics of the studio, and you've just mentioned your preoccupations and how ethics is important. Is it mandatory? Is it part of the ethics that the projects of the studio use original data produced by humans, or do you produce synthetic? Do you use synthetic data? I mean, the data you produce can be used to produce new exhibitions. I don't know if it makes sense, because I'm not a technical one. I am from another part of the artificial intelligence discussion, communications and education. But I was thinking if, because I can see you use original art all the time, and I didn't see you using synthetic data, and I think this is good because it means you are I don't know, making human more valuable. I don't know. Does it make sense?
Yes, it makes a lot of sense. I think it's a good question. So one problem that exists in the AI world is that in the limits, if you use a lot of synthetic data for training any model, it's many researchers show that the model will end up collapsing. Exactly.
Yeah.
They don't converge in training. So it just starts to output garbage if you try to use synthetic data. Of course, that's I understand that that's a very in the limits, and for an aesthetic purpose, for example, we can be interesting sometimes to use synthetic data. But the idea of the studio is not, I think, using just AI for its own sake. It's actually trying to capture the human knowledge behind all of that. So human or natural knowledge as well. So, you know, actually try to make this invisible knowledge visible. So I think that's why we always try to use, you know, actual natural data and human-made data, always ethically collected, as I mentioned.
Yeah, of course. Thank you. I have another question.
Yeah.
Is Refik a programmer as well as an artist?
Yeah, sorry, I was realizing this. I didn't give a background on Refik. Refik was born in Istanbul, and he has a background in arts. So he's an artist. He has 2 MFAs, 2 Masters of Fine Arts, one in Istanbul as well, and another in California, in UCLA. Now he's a professor at UCLA as well, and a researcher there. But yeah, he's from a design and arts background, but he always programmed with, he was one of the pioneers of digital arts. He has been doing it for more than 10 years. So one of the pioneers of using data as an actual pigmentation, as he calls it. So a thinking brush. So using it for these big projections and public works. But yeah, overall, he comes from an artist, but also interaction background.
Okay.
This is another reason that I tell my students and everybody that it's easy to fall in love with AI, because with AI you can work with many different and smart people. You do not need to be like a computer scientist to be in AI. You just need to want to solve and to create solutions for interesting problems, right?
Yeah.
And one of the nice things about Refik's work is related to what I have been telling people. It's human-centered artificial intelligence. It's AI with a humanism background, with the human in the center, and trying to create solutions not to replace humans, but to enhance, to augment our capabilities, right? Next question. You want to ask something? Please go ahead.
Thank you very much, Caio, for the presentation. I'm a huge fan of Refik. I watched the speech that they gave us here at Unicamp.
That's awesome.
And I had a chance to see their work in Gasbatlo and also in MoMA.
Ah, that's cool.
Yes, it's really cool. It's amazing to see a huge screen with the sound.
It's very different, right?
It's way different.
Very different.
I think my question that I have is a bit more technical. Every time I saw this, I saw like how AI is using the data that we have right now. I still cannot make like the connection how you can make this visual. Like for the Mozart example, art that you had, for example, you make the connections between the artwork itself, but like how do you make it possible that we can see in a way that makes sense to us? Like is that an AI output or is the human part that you have to do it?
That's a great question. I think that we do employ AI for that, but as with any other process, it's a very human-based creation as well. So for that specifically, we're using UMaps. Let me share it again. Oh, I don't have the password.
Password?
Tem a senha aí do
A senha?
computador? Eu bloqueei, fui eu, desculpa. But basically,
Auditório.
auditório. Você pode colocar para mim? Obrigado. But basically, we're using UMaps for this. It's a sort of recent dimensionality reduction technique. So dimensionality reduction, as in PCA or TSNAS or any other ones, we take the embedding representation of these phenomena. So let's go back. And we get a representation across various planes, right? So it's usually 1,000-dimensional embeddings that represent this data in this semantic way. So embeddings that are similar are close in this latent space. Embeddings that are different are more separate. And then we employ the UMAP here. What we are actually doing here is reducing it to 6 dimensions. So if we had 1,000, we reduce it to 6. 3 dimensions are plotted as colors, so RGB, and 3 dimensions are plotted as the actual position in the space. So that's how you can see the different clusters. But of course, using UMAP within itself, we are not using it as a clustering tool per se, as an industry would. So of course, we do want to have different clusters that do have knowledge embedded in them. Of course, this green area is going to be one sort of Mozart composition, and this blue one is going to be another completely different. And we use that for the interactions that you see, navigating. But it's a lot of aesthetic choices as well in constructing this. So it's not just taking the outputs. We produce several hundreds outputs, filter them, produce a lot of visuals here using many different actual design and animation techniques. So using Houdini, using these different softwares, and to reach this final work. It's a lot of work.
Very nice. So, if you are curious to know how to do it, you can do computer vision and artificial intelligence with me. And then you can get to see how these techniques work behind the scenes. Any other question? Please.
Thank you, Caio, for the presentation. I have lots of questions.
Awesome.
I could spend all day talking about this, but I'll focus on 2 questions. The first one is, how do you embed the smelling information in your latent space? Because to me it was incredible, because I've never seen something like that. Yeah. So how did you do
Okay, this is a great question. I don't know how much detail I can get into it. But basically, if you have a lot of data of anything, and you employ an unsupervised technique on it, you can get latent representations. So if you try to train an autoencoder with any sorts of data and just leave it running long enough, if you have the right model and good data, you are going to end up with good latent representations. So basically that's it. And then in regards to the image and how you can correlate, of course we had the flowers species names. So usually, if you can't really embed 2 things into the same space for technical limitations, because of course we are not developing all models from ground up, it would be impossible. You can try to use a different space to kind of correlate them. So as I was showing, the valence arousal space can make a good embedding space for correlating different entities, or in this case, the actual names of the species or natural language can be used for that.
So you don't use, for example, the molecule structure information, but you use, I don't know, a percentage of that molecule in that species?
Yeah, something like that.
Okay.
Yeah.
Okay. And the
Last one?
question, yeah, the next one is
When I get all the secrets, man.
how large are the data sets used to train your models?
Oh, very large, man. Very large. Like, for a large nature model, well, I have the data here, but it's like hundreds of thousands of hours of audio. We have millions of images for species well cataloged. This after cleaning, we have I would say I want to say something around 4 million images of species. But it really depends on the project, right? For MoMA, it was a couple 100,000, so it really depends. But overall, as I was saying, we have processed over 4 billion images already in our works for the past 10 years. The studio has existed since 2014.
So once again, thanks a lot. Very nice. And as I said before, and you also mesmerizing. Congratulations
Awesome.
on your work, and thank you also for being here.
Thank you, guys.
Excelente, obrigado.
Coloquei a distância.
Não, só coloquei.
Vai.